So I drew the triangle for this one, and we notice that it's the angle side-side case, the dreaded donkey case, right? And this is the one where they said you couldn't prove triangles congruent, and there might be two cases. So sometimes what I'll do is I'll make it myself a template for the other case. Everything's going to be the same, but maybe we might have two potential triangles here. But I just go about my normal law of sines like normal, so I'm going to do the sine of 70 degrees over 25 equals the sine, I'll look for C first because I have its opposite side is 26, and so if I'll get that the sine of C will be 26 sine 70 over 25, and so the sine of C will be whatever 26 sine 70 divided by 25 will be 0.977, and then I'll take the inverse sine of that and I'll get 77.8 degrees roughly. Is that about right? Excellent. And so, but wait, this is the ambiguous case. So every time it's the ambiguous case, you go, or maybe it was 180 minus that. Always 180. If you've taken trig, you'll know why. There's two places where the sign equals this positive value, in the first quadrant and in the fourth quadrant. And your calculator only told you the first one. It neglected to tell you the one in the fourth quadrant. So you have to do 180 minus that, and you're going to get 102 degrees. Now sometimes this 102 degrees doesn't fit. So I'm going to put, so maybe the C is 77.8, or maybe the C is 102 degrees. Now if it's 102 degrees, I'll have 180 minus 70 minus 102, and that's 8 degrees left for that one. Sometimes this is too big. Sometimes you end up getting a negative angle there. There's not enough room for it. So sometimes there's just the one triangle case. But in this case, that fits. That's fine. So I'll have two completely separate triangles, one with the 77.8 for C and one with the 102 for C. And then so in this case, in this triangle, the B will be 8 degrees, and in this triangle, the B will be 180 minus 70 minus 77.8 is 32.2 degrees. Excellent. And so now we just have to find the B's for both triangles completely separately. So I'll do this first triangle first using its info. So I'll do the sine of B over B equals the sine of A over A. So let's do that down here. So it's the sine of 70 over 25 will equal the sine of 33.2 over B. And when you do that, and I really shouldn't round that, but oh well. So I'm going to get, B is going to be 25 sine 33.2 divided by the sine of 70, and you're going to get 14.56 for that. So 14.56 for that, and that triangle is solved. Check. Then you go over to this triangle, and we'll do sine of 70 over 25 equals sine of 8 over that B. And so B will end up equaling 25 sine 8 over sine of 70. And punch that in. 25 sine 8 divided by sine 70, and you get B, in this case, is about 3.7. So we've got our two answers. Let's see if they agree. 3.2, B is about, so they got 14.2. Again, I shouldn't have rounded there. Keep all the decimals into the end. I should have followed my own rule. So if you kept all the decimals to the end, they got 14.2 here. And then the other guy, yeah, again, they got 3.6 here. because I think I rounded that angle there. But that is the gist. You see that angle side side, so you know to look out for two potential angles, either the angle your calculator gets you or 180 minus that. If it fits in a separate triangle, great, you've got two triangles. If it doesn't, you just have the one. And that's all there is to the ambiguous case. I'll do another one actually where sometimes the calculator, sometimes you get a sign value that's bigger than 1 and your calculator says no, don't do that. In that case the triangle's impossible and there's no triangle. As nice as that.